Okay, so like I said, today we're going to be continuing our look at the square roots. We're going to be working with both multiplying and dividing. Gentlemen, now is the time to pay attention. You should have been paying attention the whole time and not playing football, but I see where your priorities lie, okay? So let's continue on, though, all right? I suggest you change your priorities in the meantime. All right, number one, okay? We're going to be multiplying here. Before we actually get into some problems, though, I'm going to show you some examples right here, okay? And you'll look up here, and we kind of get some clues about what we're supposed to do. So when it comes to simplifying radical expressions, that involves multiplication, okay? You want to multiply numbers that are both outside the radical, okay? So numbers that are outside the radical, they get multiplied together. And then you also multiply numbers that are both inside the radical. So that means you multiply the numbers that are inside the radical together, and then finally you simplify the expression. Okay, so we'll start with the very basic one here. 2 times 5, what gets multiplied together here? 2 and 5, and that makes 10, right? You knew this before you came in today, hopefully, right? That makes 10. Okay, 2 times root 5. Do we multiply the 2 and the 5 together here? Why not? The 2, is it underneath a square root? No. The 5 is underneath the square root. So we cannot multiply the 2 and the 5 because this is outside the square root, this is inside the square root. So we leave it 2 square roots of 5 like that. Okay? Do the 2 and the 5 get multiplied here?
No.
Why not?
They're not both inside or outside.
They're not both inside or outside. Exactly right. So we're going to have 5 square root of 2 here. Yeah, they put the order in a different order. And if you leave it at, if you do like root 2, 5, that's okay. But it's kind of weird to do it that way because then it gets confused. Like if you write this, okay, if you write that, that's not wrong, but you can see it's kind of confusing because wait a minute, is that supposed to be root 2 times 5 or is it supposed to be root 25 there, square root of 25, right? So don't write it this way, okay? Leave your, if the number's not in the square root, put it in front. If the number is in the square root, put it, in the back there, okay? All right, now we're finally getting to some actual, straight up multiplication here. So 2 times the square root of 3 times root 5, okay? What does get multiplied together here? 2 and 5 only. And what is 2 times 5? 10. Now what about that root 3? What should we do with that? Yeah, bring it over, leave it, right? I mean, it's still part of the problem, but it doesn't get multiplied or anything. Yeah, we just leave it. That's right. Okay, how about 2 square root of 3 square root of 5, or 2 times square root of 3 times square root of 5? What gets multiplied together here?
3 and 5.
3 and 5. And what's 3 times 5?
15.
15. So it's 2 times the square root of 15. And that's what we write. Okay.
Not like 0 or something?
Nope.
Not like, okay.
We'll do 3 times 5. Okay? Now, can 15, are there any perfect squares that divide 15?
3 and 5.
So perfect squares, though. Yes, 3 and 5 divide them, but any perfect squares? The answer is no. Right, so we can't simplify any further. We're definitely done there. All right, last one here. 2 root 3 times 4 root 5. Okay? So, what gets multiplied together here? What do we multiply together here? 2 and 4, because they're both outside, and that becomes 8. And then 3 and 5, because they're both inside, and that becomes the square root of 15. Okay, and that's exactly right. We're probably not going to do every single problem, no. But we're gonna like go through something from each section, yes, for sure. But not every single problem. Okay. All right. So let's take a look at a few examples here just together. All right. So let's look at number 1. Okay. Now we've done some problems here together. Or like I've done some problems. I'll have you guys try some here too. So Sean, at number 1. Okay. What is going to get multiplied together here? If you want to, by the way, you can put a little 1 for that square root of 6, right? Because if there's nothing written, you can put a 1 there. So what gets Sean's in the bathroom. Doy. Let's go to Kendall. Kendall, what are we going to multiply together here in number 1? Okay, and so what will that give us then? Root 6 and root 6. 36? Okay. So yeah, so we'll have square root of 36, right? Because it's the 6 and the 6 are underneath there. And what else gets multiplied together here, Kendall? Yep. It's 4 times 1, or you can just, put the 4 in front there. Yep, the 4 stays in front. Okay. Now, is that the best we can do here? Are we done? Anybody? Yes, no? No. No, Sky says. What can we do here? Simplify what?
4 and 36.
What? So what? 4 and the 36? Okay, not quite. Not the 4 and the 36, just the 36. What is the square root of 36?
6.
It's 6. So this becomes 4 times 6. The root 36 becomes just a 6. And so this answer is 24. So, root 6, irrational, right? It doesn't simplify, right? If you type root 6 in your calculator, it'll give you a decimal that goes on forever, doesn't repeat regularly or anything like that. Root 6, irrational. 4 root 6, also irrational. Okay, you type that in your calculator. Again, you're going to get a very long decimal that never regularly repeats or anything like that. Okay, you can't write as a fraction. But then you take these two irrational things, irrational, you multiply them together, and you end up with a rational whole even number, 24. Okay, so something crazy times something crazy there gives you just a nice whole number, 24. A surd times a surd gives you a non-surd. Yep. Yeah, well, I'll keep it up, though. I'm just going to go to number 2. All right, number 2. Let's go to Tyler C.
Yes.
So, Tyler C., what gets multiplied together here?
All right, we do 5 times 20.
5 times 20, which is?
200.
Close.
100.
100. Anything else we have to multiply together?
And you put like -1 times 1, which makes it, you put like -1.
Yeah, because we have a -1 here, a positive 1 here, so we'll make that just a negative. Or -1 or negative. That's your choice then.
Yeah, well, you do it.
You do you. All right. So, is that the best we can do?
Yeah, I think so.
Is that the best we can do? Tyler says, yeah, I think it's the best we can do. Kendall, what do you say? Is that the best we can do? Number 2?
Yes.
Tyler's trying to influence you. So, what is the square root of 100?
10.
It is. Square root of 100 is 10. It's a perfect square. So negative 10 is our final answer here. We did it again.
That's a lot of work.
Sky.
Irrational times irrational becomes irrational. A surd times a surd becomes a non-surd. Irrational, IRR, irrational, and then becomes rational. A rational, like a rational number, like a space rational number. Yeah.
So the negative for a square root would always be on the outside of the root, the square root sign. I mean, I'm just a little.
The negative starts outside the square root, so we count it
Would you ever
as.
have would you ever have a square root of a negative 100? And then what would
Yes.
that- Then you couldn't have negative 10 then.
No, that would just be 10, right?
Right. So the square root of a negative number. Okay, a square root of a negative number. In other words, you're looking for a number that you multiply by itself to give you negative 100. Okay.
Negative 10.
So what number, when we multiply it by itself, will give us a negative 100?
Negative 10.
What's negative 10 times negative 10?
Oh, wait, that's 100.
It's positive 100, isn't it?
Negative.
Yeah, it's positive 100.
So that's
So negative, what number times itself will give you negative 100? Yeah, negative 10 times negative 10 gives you positive 100. Yeah, unfortunately, no.
No number.
Correct. Or no number that we know. Okay? The answer is there is no answer with what you guys know so far. Okay? So, in order to answer this question, you have to use something called imaginary numbers, which I know you're like, really, Mr. Whitmire? We're making up numbers now? I mean, you probably thought I was making up numbers before this, but now we definitely have a name for these things. They're called imaginary numbers. So, imaginary numbers, this would actually equal, using imaginary numbers, it would equal 10i. 10i.
Is that your imaginary
Not
number?
in this class, I don't think so. In this class, we keep it real. Other classes, you'll have imaginary numbers, so it won't be kept real in your other classes. I'm serious. The numbers,
What class can
like,
I avoid?
if you're not doing imaginary numbers, so the non-imaginary numbers are called the real numbers. So we really do keep it real in this class.
Give me an example.
Another imaginary number?
10.
I'd imagine.
An imaginary number. That's an imaginary number right there.
What about
I don't have imaginative. That's not a thing. You made it up.
That's
imaginative?
that's not a word.
Imaginative, yeah, you're making it up. Yeah.
It is.
Maybe it is. I'll Google it later, but for right now I don't know.
It probably is.
Maybe it is.
Are you trying to make
Probably.
it up?
My sister
It'll be in
was
the
a
dictionary.
math
Me
teacher, and I
saying it.
remember the time she said, oh yeah, what are your classes? Well, one of my classes is imaginary math, and I
Yeah.
thought she was
Right.
kidding. I go, oh, that's pretty
Give
good.
it AirPods.
You have to
Oh,
use your
imagination.
imagination.
The kid is the 20 negative 1 imaginary number.
Sorry?
20 negative 1 imaginary number.
20 negative 1.
Like it's one number. Like it's got 20 and negative 1 at the same number.
Oh, so imaginary numbers aren't like just anything you make up. Imaginary numbers are when you try to take the square root or an even root of a negative number. That ends up with imaginary number. Okay, back on track here though, folks. Let's continue on. Let's take a look at another one or two before I have you guys try one on your own here. Let's go to number 3. Okay, so we're going to do negative root 2 times positive root 3. So let's go to Mark. Mark, negative root 2 times positive root 3. Okay, what's going to get multiplied together here?
2 and 3.
Very good. And when we get,
6.
yeah. Anything else that multiplies together here?
No.
Isn't it negative 2?
Well, so we have a negative in front of the square root there. So it's negative 1 times a positive 1, right? So it's really going to be negative 1 root 6 or just negative root 6 if you like. If you like that. Mark, can we divide 6 by any of our perfect squares up here? Besides 1.
No.
Nope. So we're done. That's as far as we can go. Good job, Mark. Okay. One more here together. Let's go to Tyler L. Tyler L. You don't have your paper? Well, here, I'm just going to zoom in for you here so you can see it, and then you can just tell me from here. All right, Tyler L., what gets multiplied together here in this case? A and the 2. What is 8 times 2? 16. So in the square root, we'll have 16. And then 4 will multiply with what over here? Well, not the 2. It's in the square root. Yeah, there's like an unwritten 1 there that we can write. 4 times 1 gives us 4. Okay. Tyler, is that the best we can do? Or can we divide 16 by one of our perfect squares here?
Yeah.
Yeah. You'd say 4? Yeah. Square root of 16 is 4, right? We don't even have to simplify it. It just is a square root. So it's 4 times 4, right? The 4 from there, that becomes a 4. And so that gives us 16 as our final answer. Okay? So 4 root 8 times the square root of 2 is 16. Again, a nice number. Okay? 2 irrationals multiply and give us a rational number. All right. I'd like you guys to go ahead and try then numbers 5 and 6, I guess, please. Just go ahead and try 5 and 6. Okay? Take a few minutes, try 5 and 6. Okay, so try 5 and 6 there on your own paper. Shepard, Mark, 5 and 6. Turn those videos off right now. Pause them. Okay, 5 and 6, please. We have things to do. Try 5 and 6. 5 and 6. Oh, yes.
What's 12 times 15?
Do you have a calculator?
180.
What?
180.
No.
Thank you, Reagan.
Look.
So 5 and 6 times by 5 and 6.
car hit the car, they're like,
Well, that's what I'm saying. See if you can divide 180 by any perfect squares. Right. So it's not if it is not a perfect square, but it's probably you can divide it and break it out there on perfect
So
squares.
we have 5 to negative 2.
Okay.
That comes in here. Well, actually, stop. 5 times 5.
So for number 6, would I do negative 2 square root by 5 or 5 is that?
So negative 2 is outside the square root. So what would it multiply with?
Well, no, not 4. No, not 4. 2.
You have
2.5.
You have not this one.
I have no idea.
So listen, you have negative 2 here, yes? Right?
Yep.
What other numbers are outside the square root? Well, here's another square root. What's outside of this? What number did you put here?
Put a 1.
So 1 times negative 2 then.
Okay. And then
Would be negative 2, right? So that you put right there. It's on the square root.
for this one, just do 25. Okay, so
So write that. Yes, write that. Negative 2. And then 25. Now, what is the square root of 25?
5.
So you have negative 2 times 5.
So it's already in here, right?
no.
Just
Negative
put-
2
you just put-
Notice what I didn't say. I didn't say negative 2 times the square root of 5. I said negative 2
Times 5.
times 5.
So it's-
The square root disappears because you did the square root.
What do you get?
No square roots, they go away.
Well, you can already find that if you're like.
What's that? Not now, no. 215, yes.
How about now?
You got a result here.
Do you have a bus? Yeah, do you have a bus?
Can I have
Start walking off.
an add-on?
You can, but that would be an awful big price to pay for going from. So now, see if you can divide 180 by any perfect squares.
First thing you said that reminded me of 5th grade. That was my, when I was running for student government, that was my slogan. Don't pay the price, vote for Simon Says.
Did you win?
No, because one person wasn't there.
Who'd you lose to?
Yeah, Steve.
I don't even have hands.
You know, that person who wasn't there was gonna vote for me. Yeah.
Square root or
This is a society.
yes, 4 is 2 times 2. The square root of 4 is 2.
Alex, I was the vice president.
5 is not a perfect square,
Did anyone give up? What did you do as vice president?
I got that was the way.
He was vice president? Huh? You did all this stuff for like
4 times 5. 4 is not a square.
They still have it. They got
Of my old school, they had things on there.
Why'd they get rid of
Mine was separate.
What? Why'd they get rid of it?
I don't know if they were. So at my old school, we had 7 students going where each grade would get together. Maybe like our senior circles and we
Too bad we didn't have did the seniors have scripts?
Is that right?
We're going to go over it actually right now. So, all right, folks, eyes up front. Here we go. Let's take a look. Okay, so number 5, we've got Catherine. Catherine, what? Oops, I'm on freeze. There we go. Unfreeze. Catherine, what gets multiplied together here at number 5?
I have no idea.
Oh, but what numbers are there?
12 and 15.
Okay, and they're both underneath the square root, right? So they get multiplied together. What is 12 times 15? You got your calculator handy there?
If it'll turn on.
Oh, it's not turning on for you. Okay, so we'll go with Reagan's answer there. It's 180. Okay? So there it is. Were you able to get it turned on yet?
I'm trying to get it too.
Okay. We'll go to someone else then, Catherine, while you're fiddling with that. Okay? So then, Daniel, can we simplify this any further, or is it as simple as it's going to go? Okay? What does 180 divide by? Okay. 9, okay. 9 times, nope, 9 times 20, right? Okay, so we can then break that up and say it's root 9 times root 20, or square root of 9 times square root of 20, We get 3 for the square root of 9, right? And then times the square root of 20. All right, Daniel, is that the best we could do? No. Okay, what can we divide 20 by still? 4, yeah. And so we get 3 times the square root of 4 times 5. And then we'll break it up. So it's 3 times root 4 times root 5, which becomes then square root of 4 is 2. So it's 3 times 2 times the square root of 5, which is 6 square roots of 5. Okay, and so there's our answer. Okay? Now, did anyone divide 180 by something else besides 9? So 36, right. So 180 divides by 36, it's 5 and 36. So that way it was a little bit faster. You can do a little bit fewer steps, okay? Your choice, it's up to you. If you want to just use the first perfect square that you come across that works, do that, and then just keep simplifying it. But if you want to keep trying to see if some of the bigger perfect squares divide out of it, that'll make it faster for you. Okay, that'll make it go faster. Okay, so anyway, something to think about. Number 6. Let's take a look at that one. We'll go to Shepherd. So number 6 here, Shepherd. All right. What can we multiply together here? Okay. So what is 5 times 5? So in the square root, we'll still have a 25. And then negative 2, what does that multiply with? Yeah, invisible 1 in front there. So we'll have a negative 2 there. Okay, good job, Shepherd. Yeah. Shepherd, do you know what is the square root of 25? It's 5, yeah. So we end up with negative 2 times 5. And so the final answer is actually negative 10. Negative 10 for your final answer there. Okay? Very good, sir. Questions on any of these? Okay, now, Carson pointed something out earlier when I was going around, and he asked me a question. I want to have Carson kind of say what he did. So, Carson, what did you do here before you multiplied?
I broke apart 12.
Yeah, into what?
3 and 4.
So Carson saw, wait a minute, there is a perfect square in this number right off the bat. He saw that he saw he could divide by 4 here, and so what he did was change that 12 to root 4 times root 3 times root 15. Right? Still the same thing. We're all multiplication here. What is the square root of 4? It's 2. Okay? Is this okay to do this? Yes, sir, is right. Okay, that is right. So, notice what happens here. Now when we go to multiply, the 2 will multiply well with the 1 in front here, so we get a 2. 3 times 15 is 45. 2 squared to 45. And then, Carson, did you find any more perfect squares that divide 45? There are. What? 9. 9 and 5. And so we could do 2 times root 9 times root 5, which is then 2 times 3 times root 5. And guess what we get? The same answer, 6 root 5. Okay? Just like that. So, long story short here, if you can simplify the numbers ahead of time, right? If you see perfect squares inside, go ahead and pull them out if you want to. Or multiply them together right off the bat and then simplify. It's your choice, okay? Which one you prefer to do here. They both take work, right? But sometimes you can simplify it down pretty nicely, and that keeps your numbers low, right? For example, if we did it the first way, you have to do 12 times 15. Maybe you don't have to think in your head what 12 times 15 is. But Carson, when he reduced his, he just had to do 3 times 15. That's a little bit easier maybe for you to do in your head. Okay, so sometimes it's easier to simplify first and then multiply. Sometimes you just want to multiply first and then worry about doing all your simplification at once at the end. So it's kind of your choice. Okay? You get some choice there about that. All right, any questions before we move to division? Can we not? No, we must. We must.
We must.
We must.
Tomorrow.
Today. To now. Okay. Yeah. Okay.
Sounds a bit rushed.
Well, Rush. I love Rush. Okay, so here we go. Technical Warrior today, Tom Sawyer. Let's go here. Yeah, it's a Rush song. Okay. Let's get going here. So we're gonna divide now. We're gonna divide. Okay. So, simplifying radical expressions, we're now dividing. So let's again start with very easy stuff, okay? So 6 divided by 3, right? When you have 6 over 3 like that, that's a fraction. It means division 2 if you want to simplify it. And so what is 6 divided by 3? 2. Okay? Now, we have square root of 6 divided by the square root of 2. How do you think we can simplify that? Think about what we do with multiplication. If the numbers were outside the square roots, we multiplied them. If the numbers were inside the square roots, we multiplied them. So here, right, it's going to be square root of 3. We just divide the numbers inside the square roots there. So it's 3. Or root 3, I should say. Okay, how about this? Can we divide the 6 by the 2? Why not? 6 is in a square root, 2 is not. So what is the answer here? It's root 6 over 2. We just can't do it. So we just leave it. We leave it. Okay. What about here? Is there anything we can divide here?
6 root 2.
So can the 6 divide by 2?
No, 3.
Can the 12 divide by 2?
Yes.
Yes, they're outside the square root. And 12 divided by 2 is 6. So I'm going to go ahead and just you can see it right there, right? I can divide by 2 and that leaves a 1 behind. So I'm going to have 6 this times square root of 6 like that. You can put it over 1 if you want, or you can just leave it as 6 squared. It's a 6, your choice. Okay, but the 12 and the 2 simplify. They divide out. 6 times the square root of 6. Okay, can we simplify 6 times the square root of 6 anymore? Are there any perfect squares that divide 6? Besides 1? No. All right, let's keep going here. And then how about this one right here? What gets divided here in the last one? Only the 6 and the 2 because they're both in the square root, right? And so what is 6 divided by 2? 3. And so we'll have 12 still, square root of 3. Can we simplify that square root of 3 anymore? Nope. Okay. So, very good. Now, have to talk really briefly here about one other thing, okay? And that is that the simplest form for fractions with a square root, or any root, so it doesn't have to be a square root, bless you, because, of course, when we have a square root, we assume it's a square root here. When you just have the root symbol, we assume it's a square root, and then if you see like a 3 or a 4 or a 5, you'll say a third root, fourth root, fifth root, so on and so forth. We assume square root here. When we simplify fractions with square roots, okay, so what are some rules for simplifying square roots? So obviously we don't want any perfect squares underneath the square root, right? So if we have a root 75, that's not simplified because we can break that up into 25 and 3 and make it 5 root 3. That is simplified, right? There's no more perfect squares to divide 3. Here is an important one too. We don't want any fractions underneath a square root. So if you have the square root of the fraction 3/4, right? Square root of the whole fraction there, 3/4. See how tall that is? Whoop. Okay. Break it up into root 3 divided by root 4. Okay. And then just take the, well, since root 4 simplified to 2, we can simplify that, and voila, there's our answer. Okay. So no fractions underneath the square root. Break it up into root 3 divided by root 4 like that. Just like we can break up a product, we can break up a division symbol too, or quotient too. Okay, now here is, this is the key one right here. Okay, and this, you might think all of the math that we teach is arbitrary, but number 3, I kind of consider to be arbitrary a little bit. Okay, especially if you guys plan on going on to like calculus by the end of your high school career and stuff like that, you will not need to do step 3 here. Okay, so, what's that? Arbitrary means kind of like it's something that we're like supposed to do, but it's not very clear, I would say, like why we have to do it, and it's not necessary either, I would say. I think that's kind of like what arbitrary means. I have a dictionary back there, I could look it up, but it's something like that, okay? But again, you might think all this math that we're doing is not something that we really need to do, but we have to do it because we're told to. I don't know.
I mean, we have to pass high school before we get a job.
There you go, Tyler. That's the spirit. So, what do we do when we have a square root in the denominator and we can't simplify it, right? Like root 3, does that simplify any further? No. What do? We multiply by 1. Because what does multiplying by 1 do to the value of this? Does multiplying by 1 change the value of our original number? No, it does not. But we're going to multiply by 1 in a tricky way. We're not going to multiply by the number 1. We're going to multiply by root 3 over root 3. okay? Isn't that multiplying by 1, really? Because what is root 3 divided by root 3? It's 1, right? But why do we make it root 3 divided by root 3? Well, because I have this right here. Root 3 times root 3 will become root 9, which is a perfect square, and that simplifies to 3. Okay, and you see how we had a square root in the denominator, and now we don't have a square root in the denominator anymore. And that's called rationalizing the denominator. Why is it called rationalizing? Not because we're trying to come up with reasons why it's, so, but because we have an irrational denominator, square root of 3. We then change it so that it is rational, 3. You'll notice it does change the value of the numerator a little bit too, but again, remember, these are equivalent. 2 divided by the square root of 3 is the same as 2 square roots of 3 divided by 3. If you don't believe me, type it into your calculator and you'll see you get the same decimal. Finally, number 4, make sure you reduce fractions. So 8 root 5 over 2, well, the 8 and the 2 can simplify to 4. Okay? But this is the key one that's kind of funky, okay, and that later on, if you take calculus, you won't even have to do this. But we are going to do it because we're going to at least see, okay, get the practice in and stuff like that. Because I like to make things harder than they need to be. Just kidding, I don't like to do that, but here we are. Okay, so let's try number 11. Okay, first things first here. Carson, what are we going to divide in number 11? What gets divided here in number 11? Okay, hold on to that thought for a second here. Just focus, just answer the question that I asked first. We see division here. What numbers get divided in this problem? 8 and 7, okay? Do they divide evenly? No. Can we simplify? So like 8 divided by 7, if I type that in and hit math, enter, you'll see that it doesn't even simplify, right? It just stays 8/7. So in other words, this is the best we can do to simplify it, okay? Bless you, okay? Are we done then? Should we just leave the answer like this? Why not? What do we need to still take care of here? The square root? The square root where? In the denominator. Yes. We need to simplify that square root in the denominator. So, to take care of the square root of 7, what should we multiply by? Root 7. Okay, so we're going to multiply by the square root of 7 over the square root of 7 here. I know this is weird. We're in the division section of these notes, right? We're supposed to be doing division, but the division that we can do doesn't really help us at all. And so we aren't really dividing here. We're actually just going to do that rationalization that I talked about. This is called rationalization. Okay, that's like a 50-cent word right there, okay? So, we multiply. Root 7 times root 7 becomes, go ahead, Carson. Root 7 times root 7 becomes?
47. Wait, you said time.
Yep. What's root 7 times root 7?
Root
Root
40.
49. Okay. And then, Carson, what gets multiplied up here?
8 and 7.
Right. Remember, folks, when we multiply fractions, you multiply across the top, multiply across the bottom. It's most like intuitive operation that we do here. Okay, 56. 56. Okay, Carson, what's the square root of 49?
9.
Eh. 7. That's right. Square root of 56. Is that a perfect square, Carson? Look at my list. Look at my list. Is 56 up here? No, but can we divide 56 by any perfect squares? Now you might want to check your calculator if you need to. Yes, what does 56 divide by? Nope, not 9. Well, it is 8 and 7, that's right, but neither of those are perfect squares. 4. 56 is 4 times 14. And so this is going to be root 4 times root 14 all over 7. Okay. What is the square root of 4? 2. So it's 2 square root of 14 over 7. Whew. Can we simplify the 2 and the 7? Does 2 over 7 simplify? Well, let's check. You can type in your calculator if you want to. 2 over 7, math, enter, enter. Nope, it stays 2/7. So this is the final answer. Okay, there's no more perfect squares that divide 14. 2 and 7 can't simplify. We're done. Can you stick around for one more and then yes? Okay, one more, please. Just because I think it's going to be helpful. All right, number 12. Let's go to Matt T. Matt T, number 12 here. Okay, so let's look here. What would get divided here? If we were going to do the division, what would get divided here? 7 and 8. Okay, lay them straight. 7 divided by 8. Math, enter, enter. Okay, does 7/8 simplify? No, it does not. It stays 7/8. It doesn't divide evenly or anything like that, so we're just going to leave it as 7/8. All right, so there's that. Are we done then, Matt? What else do we need to do here? Right, square root in the denominator, we got to eliminate it. So we're going to do that by multiplying the top and bottom by what? Root 7, square root of 7, yeah. Okay, use the square root to help you see. Because what are we really doing here? If I use this number and multiply by it, what will I create? A perfect square, because it'll be 7 times 7. Okay, that's why we picked this number, because we create a perfect square, so we can then take the square root. Okay. So Matt, in the numerator, what will we have now? 7 square root of 7, you got it. And then in the denominator, we'll have 8 square root of 49. That's right. Okay, you can see why we had to do multiplication first, because we have to multiply in some of these too. Okay, Matt, now how can we simplify? What is root 49? It's 7. So we have 7 square roots of 7 over 8 times 7. Now, before I multiply that 8 and 7 together, what can we cancel out here? The 7 and this 7. Okay, we can cancel them out because one's in the numerator, one's in the denominator. It's all a big product there. And so we're left with the square root of 7 over 8. Okay? That's our final answer. Questions on any of that? All right, let me say. Now let's say, Mr. Whitmire, how am I supposed to know that these 7s can cancel out? What would have happened if I done like 8 times 7 there? What would have happened if I did 8 times 7 and got 56 and I had that 7 square root of 7 over here? How am I supposed to know? How am I supposed to know that this can simplify still? Type 7 over 56 into your calculator and hit math, enter, enter. And you'll see you get 1/8. 1 root 7 over 8. Right? So the 7 and the 56 simplify to 1 over 8. And yeah, you want to go now. Yeah, that's fine. Yep. I want you to stick around for one more too. Okay? And then you can go. We're going to do one more here together, and then I'll have you guys try one or two on your own. All right? 13. Okay. 13. Let's go to Alex.
Yes, sir.
Yes, sir. What gets divided here, Alex?
The 6.
And?
The
2. Okay, so 2 divided by 6, right?
3.
So careful.
That's the other way around.
Yeah, 6 divided by 2 is 3. 2 divided by 6, yeah. It doesn't divide evenly, but Reagan, you're on the right track there in that it does simplify. So again, if you're unsure about fractions, 2 divided by 6, math, enter, enter, we get 1/3. So we can call this then the square root of 1.
What? Enter.
Math. So math, and then fraction, enter. And so you see, it's going to take your answer, convert to a fraction, but it converts to a simplified fraction. So like 2 divided by 6, that's a fraction, right? Hit math, arrow, and now it's going to take this 2, 6 and convert it to a simplified fraction, 1/3. Very nice. You can do it when you have decimals and stuff like that too. It'll convert decimals to fractions for you too. So, Alex, what's the square root of 1?
1.
1, yeah.
That's what it is.
Yeah, that's it. And the square root of 3, can we divide any perfect squares out of the square root of 3?
No.
Yeah, just 1. That's not helpful.
You can use the calculator.
You can guess and check with the calculator, but there's no perfect squares there that divide root 3. You can get a decimal, but it won't simplify to a nice number yet. All right, Alex, is this a good final answer then?
No.
No.
Does not look like it to me.
What's the problem here? What do we have that we need to get rid of?
These
the square root in the denominator. If this was flipped and the root 3 was on top, we'd be fine.
No denominator.
But we don't want to square root in the denominator. So we're going to multiply the top and bottom, Alex, by? Close.
1. 1 over 3. 3 over 3, okay.
Nope. Root 3 over root 3. So you multiply this by itself over here, but it's really by multiplying by 1, right? Because that simplifies to 1. Okay, Alex, 1 times root 3.
1 over root
1 times root 3.
3.
1 times root 3.
1 root 3.
Root 3. Or 1 root 3. Root 3 times... No, you didn't actually.
Yeah, kind of. It's all the same.
We'll play it back later if you really want to, and we'll
Yeah.
we got the transcript right here.
Oh, okay.
All right, so
The transcript.
yeah, you can go back on YouTube tonight, and then you can listen.
Ah.
Root 3 times root 3, Alex.
1 root 3. 3 root 3.
Hang on now. Square root of 3 times square root of 3. Because they're both in the square root, we're going to multiply them together. So what is it?
0 or 1?
We're multiplying.
Oh, it's 9.
9. Yeah, root.
You said multiply?
Yeah, I did. Because again, here it's a 1 times, well, the one number in front here is a 1. So it'll be 1 times 1, and you still have the root 3, so it's 1 root 3 right there in the numerator. Here it's root 3 and root 3. They're both in the square root, so you multiply the 3 and the 3 to make the 9 there. Is that making some sense? Alex, I'm talking to you.
It's kind of like, I was confused.
When you multiply, Alex, Dylan, when you multiply, okay, you multiply the numbers that are in the square root. 3 times 3 makes the 9 there, okay? Alex, what's the square root of 9?
3.
3. So we have root
Wait, why
3
would we write it this many times?
because we have to simplify. And what does it mean to simplify? We have to make sure all these things are met. There should be no perfect square factors under the square root. That means we shouldn't have any perfect squares we can divide out. There should be no fractions under the square root, which we didn't have. But this is the key one. No square roots in the denominator. And you need to reduce any fractions and stuff. So here, why didn't we stop like right here? Well, because we still have the square in the denominator. But once the square root of 9, it becomes 3. No more square roots. Good. And then we can stop here because there's no square roots we can divide out of 3. We're done. Okay? It's a lot of steps, Alex. You're right. All right, I'm going to have you guys try 14. Just 14. Just try 14. Okay? So give 14 a try. There's a couple different ways you could go with this, so don't feel like you have to, be the same as your neighbor. You should have the final answer, same final answer, okay, in the end. But you might take different paths.
If I get this right, can I start shooting?
Dylan's first after this. And then you can go mark out. You want a new pen? Okay. You want to just throw that away then?
Sure. Because it's leaking everywhere.
Yeah, I don't want you to be all messy.
Wait, 1, 2, 3. 1, 2, 3. Somebody that on camera.
Are you guys rock, paper, scissors for the bathroom?
No. Shove it. You're working very hard to that. 100 extra kind of points.
Look at that.
Oh, great.
The same one. It's cool.
So, what gets divided? So, you can put it equal, but
Do it.
simplify. So, okay, right. So, man, sorry. So then, yes, you're going to say, take that root 7 and square the denominator and multiply by root 5. You're on the right track. Yeah, just want to make sure you're writing the right thing. Again, folks, let's try number 14.
I'm not good when I'm on 14.
Check what gets divided first. What will we divide here? And so, do they divide evenly? No, but you can simplify.
So then you would do 5 times 3.
21 divided by 15, math enter. Simplify the fraction. Yes, 21 15 simplify to b. And then you can then rationalize from there. So you got the square root of the denominator, right? So you're going to also at this point, so carries that divide out and those are so the number of multiples.
Nah, there's no vape or anything like that. It's called a USB cable, okay? USB port. It's not true. It's lit. No, smell it. People died for that in China.
What is
In the factories.
What's inside? So quick.
So those don't
We were in one shot.
What's one shot? What is 21 by 15? So then change that to root 7 over root 1.
I probably wouldn't have noticed.
It's work, but it's not good when it's so hard to sharpen. Rationalizing the word, the denominator.
Alright, Mr. Boy. Playing more? Shepherd.
On the top of the font by square root of
I'll come for the clan war. No, it's just we need to make the clan public.
Not stuff in the
It's in there.
I lost my account. I have like an old account.
No, we still find a way. We track it down.
Alex, are you done yet? Alex,
Sorry, sir. Watch that end.
you really are.
Yeah, we don't.
Well, I got a fraction, so I think I.
If you have a square in the denominator, call it the denominator, you rationalize it. We did.
How do you rationalize?
Number 13.
I walked up to someone one time with a dowel and I just like, bam.
Dylan, go back. See right here? Had a square in the denominator and multiply.
What do I do that? For like 7 different.
So, okay, what's root 7 over root 5, right? Got it. I haven't figured that out yet.
How about none?
No, not none.
Are you sure? Because I just bought a brand new Xbox game and I wasn't like that. I got full surprise for it. I got the brand new.
For the last week of the race week will be a battle. Will be very intense. Like, will everything be rushed? Will everything be rushed?
Oh, like our class?
Yeah.
No. You know why? Because it's a year-long class. And so,
By the way, do I have you again? I think I have all yours.
Who do you have?
actually, do
I think this is a year-long class.
Stop by. Maybe. I try.
come back and be like, well, because the other two met, 1B teachers are in the same hallways. Yeah, it's blue.
You should visit wood shop sometime for fourth period next semester.
Oh, yeah?
Although I suggest wearing like protective gear because it's like a war zone.
Yeah.
What?
Dylan, back to your seat, please. Thank you. Dylan, Dylan, no. You started going, keep going.
They also got
Before they got there really serious, they cut a finger off or anything, but no, none of that happened. So guys just
all we can do is
half of wood shops.
there's a fire in the school. The school burned. These walls are wood.
Very hard.
Believe me.
Very hard. Yeah, but it's very hard to light.
If you set an old church on fire, actually, it was they rebuilt the hospital. This is live. Well, you have to burn it down. They use the buildings, the old ones. Very thousand. Question is, what am I now?
That was on a mental hospital when they knocked it down.
I'm talking about regular hospitals. My house was
My house is not even joking. My house is
where do you live?
very shallow.
Where do you live? Were they used as slaves? Where do you live? Why the fuck do you come all the way down here for some
Alex.
Yeah, wow, Alex.
Wow.
You're sitting there. Okay, sorry.
Why'd you say that? Come on, Alex.
All right, folks. Eyes up front. Let's take a look here. We're going to look at this one. All right. Okay, so look, guys, I'm going to tell you right now. I hear you when you say that these things are complicated, right? I get it, right? When things are nice and easy, everyone wants to just do them, get them done, we're good to go. But then when things get hard, some of us start to like give up and be like, whatever, I'll just goof off and all that stuff, okay? Algebra 1B, the class you're moving into next semester, is going to have more things like this where it gets more complex, more steps are involved, okay? And so you need to really develop within yourself, okay, the perseverance. That means sticking to something even when it's difficult, right? Okay, and just determination, okay? Because it's not going to get easier in 1B. It's going to get more complex. I'm not going to say it's going to get harder. It's just there's going to be more steps and stuff, okay? This is a taste of that, all right? So if you want to be successful in 1B, you got to prepare yourself, all right? So that being said, you can get this stuff, right? You can. You absolutely can, but sometimes it just requires more practice. So, number 14, let's take a look at this one. Okay, again, we are dividing here. Okay, does 21 divide by 15 evenly? No. Okay, but does 21 divided by 15 simplify? Yes. Okay, so you type in your calculator, right? 21 divided by 15. You get a decimal. We don't want to have decimals in our square roots just yet. We'll hit math, enter, enter. We get 7 over 5. So this is equal to the square root of 7 over the square root of 5. Okay? Is that finished? Are we done with this problem now? No. What's the issue here still? What is the problem? The denominator has a square root in it, okay? We cannot be done if there's a square root in our denominator, okay, for right now. Again, later classes, you take calculus, you can stop, okay? But right here, we have to continue. So, we're going to multiply by what?
What are we going to multiply by, Matt?
By close.
What kind of a 5?
Square root of 5 and the square root of 5 on top and bottom. Again, why the root 5? Because we're trying to make this thing a perfect square in our denominator. We have to do by root 5 over root 5 because that makes it just 1. So we're not really changing the value. We're just going to change how it looks. Okay? So root 7 times root 5, what gets multiplied together here?
This right here?
7 and the 5. Root 35. Okay? Over, what's root 5 times root 5? Root 25. Okay? Now, you might look at this and say, Mr. Whitmire, that's also got square roots in the numerator and denominator. But what do we have in the denominator? What can we do with the denominator? What's the square root of 25? 5 is right. And can we divide any perfect squares out of 35? Nope. We're done. Root 35 over 5 is our final answer there. Okay? I want to look at one more together, and then we'll stop. Okay, and then we'll stop. I know we only have 7 or 8 more minutes anyway, but we'll stop after this next one. But I want to do one more just because I think it'll be helpful. Okay, so let's see here. Do I want to? Let's jump down to 17. Let's jump down to 17. Okay. What? Okay. What gets divided here? So what's going to get divided here? Ben. Ben, what numbers can we divide here in number 17? 15 and 6. Okay, so let's go ahead and type into your calculator 15 divided by 6. Decimal. But math, enter, enter, it does simplify to 5 halves. So I can rewrite this as the square root of 5 over 3 square root 2, like that. Okay, so the 15 and the 6 divided 5 over 2. Okay. Are we done here, Matt S? Is this a good final answer? No. Why? Yeah, the thing on the bottom. Square root or root 2. Yep, okay. So, Matt, we need to make this a perfect square. So we're going to multiply by what? What does this tell us to multiply by then? Yeah, root 2 again. And then we'll do a root 2 on the top, too. Again, we're really multiplying by 1, so it's root 2 over root 2. Okay? Liv, do you mind if I come to you now? All right, so you want to finish writing there, and I'll let you. Okay, so Liv, what gets multiplied here in the numerators?
5 times 2.
Yep, so that's 10, right? Okay, the 3 will multiply with, well, is the, no. What number's in front right here? Yeah, so we'll do 3 times 1, so it's 3. And then, yeah, the 2 multiply, yeah, root 4, very good. Okay, Liv, what is the square root of 4?
Square root of 4 is 2.
So we have the square root of 10 divided by 3 times 2, or the square root of 10 over 6. Liv, are there any perfect squares that divide 10? No. We're done. Okay, we're finished there. Alrighty. We are not done just yet. All right, I guess turn the page one more time here. I'm sorry. I thought we were reaching the end here. I want to look at one more thing. My apologies. Okay. All right, 1 and 2, you guys can do those, no problem. That's multiplication. Number 3, and I'll just show you this one here because I think all the rest are kind of similar. Yeah. Number 3, what do we got to do here for number 3 that we haven't seen before in these problems?
Parentheses.
Yeah, with the parentheses, we need to distribute. So it'll be root 2 times root 3, root 2 times root 5. But it's still the same idea. Okay, what is root 2 times root 3? Root 6, square root of 6. What's the square root of 2 times the square root of 5? 10, root 10, square root of 10. Okay? Can we subtract these two?
No,
Why not?
don't work with that.
Well, they're both underneath the square root.
They don't. Doesn't have a lot of work.
Okay, so it didn't simplify down. How does subtraction work? If we can subtract things, they must be what? Like terms, right? This is a root 6, this is a root 10. They don't subtract. If we were multiplying, if it was root 6 times root 10, can we do root 6 times root 10? Yes. Okay? We can't subtract these because they're not like terms. But you don't need like terms to multiply or divide, right? We don't need like terms to multiply or divide. So if it was root 6 times root 10, we can do that, no problem. We do root 60. But since it's root 6 minus root 10, okay, they're not like terms we can't combine, we leave it the way it is. It's the final answer right there. Okay, that's it. Number 7? Sure, let's take a look at that one. Root 5 times this, root 5 times this. Okay? So, the number in front of the root 5 there is a 1, right? So it's the 1 will multiply with what over here? The 3. So we get 3. And then the root 5 will multiply with what over here? Root 5. So it becomes root 25. Okay? Minus, and then 1 root 5 times 4 root 3. The 1 will multiply with the 4. So it's 4. And then root 5 will multiply with the 3. So it becomes root 15. Okay. Now, is this one done, or is there anything more we can do? Simplify root 25. It's, what's the square root of 25? 5 times the 3 gives us 15. Okay. Can we simplify any further here?
Yes.
Do we have like terms? Yeah, no like terms. There's a root 15 and there's a normal 15, and so they're not like. Okay, they're not like. So we're done there. Okay. Sorry, folks. So turn over to the back, please. Okay, turn over to the back. I know. This is going to be your homework. Are you ready? Oh, no. So I want you to do not all of them. 21, 21, 23, 25. Okay, 21, 23, 25. And then I want you to do 15. Is there a bear in here? 15, 17, 19. It's a grizzly bear. It's 6 problems, and 3 of them are adding and subtracting. You might have to simplify some, okay?
What should be long?
Sorry, 21, 23, 25, 15, 17, 19.
Wait, Mr. Woodbine, are you going to check the homework like tomorrow?
That's weird.
Mr. Webb.
Okay, sorry. Question.
You want your pen back?
You can keep it. Just don't let your friend break it again. How about that?
Yeah, that happened in government.
Yeah.
Okay.
We're looking at having a quiz tomorrow. Quiz tomorrow on this. We'll review some and then quiz. Okay, quiz tomorrow.